We will now move on to the last part of the basic modeling and simulation tutorial. In this part we'll deal with the built-in components of SystemModeler. You already encountered some built-in components in the last tutorial. Here we'll take a bit more structured approach and look at an overview of how the components in SystemModeler are structured. We'll learn how to browse for the components in the class browser, and we'll learn how to search for them using the search field. Once we've learned how to locate the components, we'll see how we can understand the built-in components better by accessing the component documentation and by finding out how the components have been used in other models and how they have been used as subcomponents in other components. We will also learn how to put this knowledge to the test by creating a model from scratch using drag and drop. Lastly, we will go over how additional component libraries can be added to SystemModeler and how these can be organized. I'll go ahead and open up a new session of SystemModeler. We will start by expanding the Metallica standard library in the class browser. Here you can see that it's simply labeled as Metallica. As you might have seen previously, this library consists of different packages from different domains, such as the electrical domain, magnetic, mechanical, and so on. When you open up one of these packages, let's expand the mechanics package here for instance, you'll see that it's further subdivided into sub-packages. The mechanics library, for instance, expand further into a 3D mechanical library, a one-dimensional rotational library, and a one-dimensional translational library. If you hover over these packages, you'll see a description of what they contain. This is true for the top-level packages as well. Going down further one level, you'll find some additional divisions. You'll find packages that contain a collection of runnable example models. These are often a good way to understand how components should be used. Further, you'll find different building blocks that you need to create models within a certain type of domain. In this case, a one-dimensional mechanical system. The component package contains masses, springs, dampers, and other things you need for this. Below that, we have the sensor package. These are typically components that will read a certain state in your model, the position of something, the relative speed between two parts, and so on, and convert it into a real valued signal. While SystemModeler allows you to access every single variable in your model after simulation, using a sensor is a good way to highlight the most important signals. It can also be used for feedback loops and to mimic real-world sensors, such as a speedometer. The sources subpackage provides you with different ways to interact with your models. For example, you can set the position of a mechanical part according to some input signal, or apply a force, and so on. The interface package contains the parts needed to build your own mechanical components, or whatever sub-library you're looking at. Building your own components is beyond the scope of this tutorial, so we won't be exploring it here. Looking at the other packages available, you'll see that the general structure is present in most of them. Some have additional packages, such as the media library here, for example, in the thermal fluid heat flow library. But most have the examples, the components, the sensors, the sources, the interface. Since components might be distributed across multiple packages, if you want to find something in particular, a good way could be to search for it. Say that we want to find a spring. We can type it in the search bar in the class browser. Turns out, built into SystemModeler, there are a lot of different types of springs. We can now narrow down the search by using wildcards. If we, for example, know we're looking for a one-dimensional spring, we can start by typing in translational to indicate the translational library we were looking at previously. Then we can use an asterisk to indicate a wildcard search, followed by spring. We found two types of spring components here. Say we want to know more about how we should use the spring. With it selected in the class browser, press F1 on your keyboard to bring up the documentation for the component. I'll scroll in a bit here for your benefit by holding down Ctrl on my keyboard and using the scroll wheel. Here you will find information on how to use the component. For example, this suggests that the spring should be put between two sliding masses, or between a sliding mass and a so-called fixed component. You can see descriptions of the connectors on the component. You can also see descriptions of the different parameters that you can set in the model. More importantly, you will also find cases where this class is used as a component in other example models by expanding the Used in Examples tab. These models will give you an understanding for how the spring can be used. You'll also find other components where the spring is used as a subcomponent. Here you can see it as a part of a more general three-dimensional spring. Click on one of the models and you will enter the model documentation. To view the diagram of the model, click the model name in the navigation bar. The model will open in the diagram view of Model Center. Here we can locate the spring in the diagram. Using the information we've gathered so far, I'll create a simple model using the spring. First, I'll switch back to the model I had from the start. Then I'll drag the spring into the diagram view of the model. Then I'll expand the translational package again and add a fixed component and a sliding mass and connect them all together. To make the model a bit more interesting, we can add something that pushes on the mass, like it did in the spool with the preload that we accessed from the documentation. Let's bring that back up again. I can double click in the diagram view to fit it to the window. Here we can see a force component that pushes on a sliding mass. Let's mimic that in our model. If you recall from the introduction, this force component will be found in the sources sub-package. We have a few different sources to choose from. Here I'll drag the source that creates a pushing force upon the sliding mass into the diagram. Now, how should we connect this component? Say we want to push the mass into the spring. Just as you open the documentation from the class browser, you can open the documentation by selecting the component in the diagram view and pressing F1. Let's look at the documentation for the mass component. I'll scroll in here again to make it easier to read. Here it will tell us about the sign convention for this component. A positive force at the flange called flange A, that's the filled green square, will move the mass in a positive direction, and a negative force will move it in the negative direction. The same is true for flange B. So we could either connect the force component like this, or like this. In my case, I'll go with the latter, since it makes a bit more visual sense. In terms of simulation, it makes no difference. Now, it looks like we need to connect something to the left side of the force component. This connector is a bit different from the others, and if we try to connect it to one of our green connectors, Model Center won't let us do that. The connectors are incompatible. Again, we can look at the documentation. We'll look at the documentation for the force component. It'll say that the input signal F can be provided from one of the signal generator blocks of the Metallica blocks.sources subpackage. The blue arrow is what indicates that this is a real valued signal. As you do more modeling, you will learn to recognize the different types of connectors and where the components are usually found. A quick summary can be seen here. We can now go into the blocks.sources library as suggested. We could use a step component here. It can provide us with an initial negative force that pushes the sliding mass into the spring and then sets the force to 0 to let go of the sliding mass. We need to set a few parameters to do this. Some documentations, such as the step block, will have descriptive images that show you how different parameters affect the component. Here you can see that the offset will be the initial force before the step. The height is the step height, and the start time is when the step happens. If we want to have a negative force that disappears after the step, we'll set a negative force as the offset value and then set the height to be an equally large positive value. So if we set the offset to be -1 and the height to be 1, and we'll set the start time to be, for example, 5, then we'll have an initial force that pushes the mass into the spring and then lets go after 5 seconds. You can now simulate and explore the model that you just created. See the extra assignments in the attached notebook to get more information about this model. Now let's look at what you can do if the domain you're interested in modeling is not included in the Metallica standard library. Additional libraries can be installed into SystemModeler. These can be found on the library store on the SystemModeler website. One way to access the library store is to go to the documentation and click on Additional Libraries. Then click Find Additional Libraries. Here you'll see some extra libraries from many different domains, many of which are free. Go to one of the libraries to read more about it. You'll find a description of the library, video tutorials showing you how it can be used, and examples from modeling within that particular domain. Click the download button to download a free copy. Once the file has been downloaded, you can double-click it to install the library in SystemModeler. Alternatively, you can drag it into your current SystemModeler session. You'll be prompted to install the library. Click on Install Library to install it. the documentation for the newly installed library will appear. You'll find all the new components associated with the library in the Libraries tab of SystemModeler. To manage your installed libraries, go to Tools and click on Options. Then select Metallica Libraries. Here you can see all your installed libraries. You can right-click it to uninstall it. You can also deselect it so that it won't get loaded together with SystemModeler. You can also add custom library paths to load Metallica packages upon start of SystemModeler. That's the end of this tutorial. We recommend that you have a look at the extra assignments in the attached notebook, as these will give you a deeper understanding of using the built-in components of SystemModeler. So let me quickly recap the content of this tutorial. Here we've learned how to find the built-in components in SystemModeler, and we've learned how they are organized. We've also had a look at the component documentation and how to find out how components have been used in other models. Using this knowledge, we built our own model from scratch using drag and drop. Then we had a look at the SystemModeler library store, where new domains can be added to SystemModeler, such as the biochemical domain. Thank you for watching this tutorial. We'll open it up for questions from the attendees now.